So here is a set of lights which I believe are identical to the ones that Phil purchased, and for your $16.99 from Amazon you get 200 lights, a power supply which is also a remote control receiver, a remote control and a spare battery. The remote actually had a battery in already, so they've given you a spare. And the reason I like these lights is that they give you a nice warm white effect. They also give you a colour effect, but unusually they allow you to do something in between. So if you've got a pastel shade 1, which just takes the harshness off the normally very intense colours, and you've got a second pastel shade. Now the camera doesn't really do it justice, but it's actually quite attractive. It's got a very soft hint of red, green, blue and yellow in amongst the warm white colour. And of course it does all the normal flashing and fading things, but they're a bit annoying. I don't know if this is in focus. There are also 4 levels of brightness, so they're currently at their lowest level, and the power meter there is showing 1.75 watts. If I turn it up to the next level, you get 2.9. The next level, 4.5 watts, and the brightest 6.3 watts, and that is very bright. You'll also see, I don't know if that's going to focus either, but the power supply maximum rating is 6 watts. We'll come back to that later. Well, the next thing I wanted to do was just to do some basic safety checks, just to establish whether they are as lethal as the ones I found in ACR last year, which had basically rectified mains pass straight out onto this really thin type of wire. Obviously completely unacceptable. So these ones have a loop through connector. You can actually connect 3 sets together. So this is going to be a good place to measure and see if we can determine whether there's anything unpleasant on these pins. Right, so we'll just take a quick look at this set of lights from the point of view of safety. I'm measuring DC volts across the connector at the end of the line there, and I've got 22.7 volts DC. There is also actually an AC component there, 10 volts. We'll see later there is actually some pulse width modulation going on even at the brightest setting, which they're on now. So that's looking fine, but what about between either line and earth, that mains earth? That would be quite interesting. So I'm going to disconnect one side of this, put it back to AC, and connect this probe to mains earth. Oh, and rather alarmingly, we seem to have quite a high voltage there, 87.3 volts on one side. If I connect to the other side, again 87 volts. Now actually that is not a problem. That is common to pretty much all switch mode power supplies of this type, and I believe it's due to the suppression capacitor that sits between the secondary and primary side. Now hopefully, and of course you can never tell, that someone's fitted a proper class Y capacitor in there that can't fail short. But just to prove it is a very low source of current, I've got a 100k resistor here, and if I actually, which is also connected to ground via this black wire, if I touch it to this side here, you see I very quickly bleed that voltage down to something quite safe. And similarly, if I do on this side, again take it down to something acceptably low. And just to prove that it's not an issue particularly with these lights, this lead is connected to, it's the lead I use for charging my little cycle computer, and it's on one of these USB 5-way, 4-way outlet things. And if I do exactly the same trick with that, so if I measure from one of the pins, and you see I've got a much bigger voltage on there, I've got 110 volts, which looks quite alarming. But again, if I bring in my 100k resistor, there's nothing really there. It goes down to low voltage when you bleed it off, and it's, you know, I can touch it, it's quite safe. And in fact, another way of looking at this as well, if I reconnect that back to my set of lights here, if I put the meter on its microamp range and look at that, okay, so we've got 55, 54 microamps to earth, so it is a very small current that's actually available between either of these wires and earth, and I think you'll find that's the same on most switch mode power supplies. It doesn't mean that there aren't faulty ones out there. I've seen some horrendous things on the internet where there is no proper mains isolation between the primary and secondary sides, and obviously without smashing it apart and looking in it, you can't see how well constructed it is. But all I can say is that at this moment in time, it is not putting a dangerous voltage on those wires. I mentioned that I was going to say something about the output power rating of the transformer. So it's rated at 6 watts, and with one set connected at maximum brightness, you can see we're drawing 6.1, 6.2 watts from the main supply. Now I know that's input power, but it probably is reasonably efficient as a switch mode supply, so it does tend to suggest it is probably outputting close to its maximum 6 watts just with one set connected, which did make me wonder what actually happens when you connect additional sets. The manufacturers say you can connect 2 further sets to the connector at the end. Does the supply actually output 12 watts, 18 watts in those circumstances? Now I don't have additional sets to experiment with, so the best I can do is to load this with a resistor, and I've got a 200 ohm resistor here. Now if the power supply continues to output its rated 31 volts, call it 30 volts, that should give me an additional 4.5 watts of load, so 30 squared over 200, 4.5 watts. This is only a very little resistor here, so I can't do this for very long, assuming it does get close to its output power, but here we go. Okay, so the lights do dim somewhat, and if we now look at the power consumption, it hasn't gone up very much, so we've only gone up to 6.4, 6.5 watts, which does tend to suggest that really that power supply is only going to be able to deliver 6 watts into all of the sets that you connect to it. I can smell that resistor getting hot, so that's going to be disconnected now. Yeah, and I don't think that's a problem. As we've seen from Phil's excellent display in ACR, the lights are all plenty bright, and if I dim this down to its minimum setting, which only consumes 1.7 watts, they're still plenty bright. So 6 watts shared across 3 sets, not a problem. So next on the list is just how do they get the switching between warm white and colours. Now I'm going to go into a bit more detail later at the effect where you get the pastel in between shades, but basically, very simply, what they've done, each LED has 2 chips in it wired in opposite polarities, and when you put DC in one direction, the warm white chip lights, you put it in the other direction and the colour chip lights, and there's 4 different colours, blue, green, red, yellow, and it is actually yellow. They haven't just used warm white, it is actually a separate yellow. So I've got them connected now to the bench supply, and I've brought some up here so you can see. We'll just see, sorry about the flickering on the bench meter, it's just how it is, it's not flickering in real life, but so anyway, we'll turn them on, just see what point they actually start to illuminate. Where are we? Voltage. So I can just see them starting to come on now, 24.5 volts. Keep going up till there. So we register some current. Okay, there we go. 27 volts, 42 milliamps, and they're on, and they're pretty bright at such a small current. That's not bad. And then if I basically, I'm going to swap the polarity round on here, and now we've got the warm white. Now the thing I was really amazed with, with the warm white, you've got exactly the same current as with the colours. 42 milliamps there, swap it around, 42 milliamps there. And I was really scratching my head to work out how that could even be possible, because red, green and yellow LEDs have a much lower forward voltage drop than blue or white ones. So they can't have done anything clever with resistors, because basically it's the same LED package, just wired with two chips wired back to back. So I was wondering how on earth they've managed to present the same load effectively, irrespective of how you connect the polarity. And the answer to that is coming up very soon. Okay, so have a look at the LEDs in this set, and this really gives away how they've done this trick of having the same forward voltage drop whichever way the polarity is and whichever combination of colours are on. So here are the four different colours in the set. Now you probably know that a warm or a white LED is just a blue LED with a phosphor blob on it. So the warm white chips are here, here, here and this one here. And the colour ones, all they've done, instead of using an actual LED dye that emits colour at that wavelength, which is what you commonly get in sort of normal LEDs, they've used a phosphor blob in the same way as they've done for the warm white ones. So here's the green phosphor, red phosphor and the yellow phosphor, and the blue chip is just uncovered to give the blue light. So essentially all of these 8 LED chips are actually all blue LEDs, just with an appropriate phosphor over them to change the colour. Hence the behaviour is exactly the same, the electrical characteristics are exactly the same, whether they're connected with all the warm white ones on or the colour combination on. And if I go to the next slide, where I've just put a little bit of current through them, there you can see the colour ones illuminated, green, blue, red and yellow, and then the next slide shows the warm white ones illuminated with the opposite polarity. So just have a quick look at the construction of the set. You've got two wires, two thin wires from the power supply, and it's got a removable connector on the end there. Those wires run to the first LED here, which appears to have 6 wires going into it. So you've got the 2 wires going in, 4 coming out, and then the next LED you've got two wires in, 2 out, and then these 2 wires run all the way to the end of the set, right through to the extension connector at the far end. So anyway, for the first 20 LEDs, you've got the 2 wires in and out, and the same if I show you here, and then the 2 that bypass that. And then when you get to LED 20, you then find that between LEDs 20 and 21 there are actually only 3 wires. So you've got the 2 wires that just carry on through, 2 wires come in from LED 19 into LED 20, 1 wire from LED 20 to LED 21, and then from LED 21 you go back to the 2 wires in out until you get to LED 40, and then you've got a single wire between LEDs 40 and 41. And we'll have a look now at actually how that is, how the electrical circuit is made. So we'll just have a quick look at the electrical construction of the set. So as I showed on the bench, they're wired in blocks of 20. So there's the first block of 20. I've obviously only been able to show 5, but there's the first block of 20 in parallel, and then that block of 20 is in series with another block of 20, and obviously there are 10 blocks of 20 to give you the 200 LEDs in the whole set. And that makes sense because that little power supply is roughly 30 volts output. You want no more than 3 volts across each LED, so by having a 30 volt supply and 10 blocks in series, you've got your 3 volts each across each parallel block of 20. You've got a lot of cable resistance actually. It's a very thin wire, and I measured just over 5 ohms per leg, so you've got 10 ohms round trip. And I also mentioned that the first LED appears to have 6 wires going into it. In fact, a pair of them is just a join, and similarly at the other end as well, the far end where the follow-on connector is, they're just joined. So you can see the construction there, and if I go to the next slide, I've just roughed in the current path. So you've got current through your first 20, then in series with your next 20, which are in parallel, in series with your next 20 in parallel, and so on for the whole 10, and then returned to the power supply. And obviously these can be connected either way round. In this diagram it's shown current going through the, so this side would be more positive, current lighting the coloured LEDs, but if you flip the polarity here, then the current's going to go this way through the warm white LEDs. Okay, final segment of the video, and we'll just have a look at the electrical signal on the wire to those LEDs and see how they achieve the mixing of the warm white and colour effect. So if I turn this on, now unfortunately you can't see the LEDs now because we're just on OBS, but I'm currently on maximum brightness and the warm white setting. I'm also using a ×10 probe, so it looks like we've got 30 odd volts here from the 0 line here. You'll also see there is actually some pulse width modulation going on, even though the lights are on full. So if I turn them down, that's the next setting down, lowest setting. So that's how they're achieving the brightness settings, but there is still some capacity when they're up full. There's not a full duty cycle there. So that's the warm white. If I press the remote button now to select the coloured section, and there are the colour LEDs on, and as you can see it just flips the polarity. So warm white's on, colour LEDs on. That's all it's doing, is flipping the polarity. And now if I go to the first of the pastel effects, you can see we've got approximately 1/3 warm white and 2/3 colour. That's the first pastel effect, and if I go to the stronger pastel effect, you now see we've got roughly 2/3 warm white and 1/3 colour, and then obviously these things have fading effects that change the ratio of the white to warm white, or basically change the ratio of the polarities to give you the fading effect. I'll go back to the fixed. So that's how they do it. It's really simple. Obviously there are sophisticated addressable LEDs available with red, green, blue and white chips in that you can get any colour you want and do really clever things with. This is not that. It's a very cheap domestic set, but I think it's a very nice effect for the money.